All right, on 7.5, we're going to be graphing square roots and cube roots. So first of all, we need to know that that's what a square root is. That's what a cube root is. And exponentially, it looks like x to the 1/2 or x to the 1/3. Those are the same thing. If you put them in your calculator, what happens is that you get, for a square root, you're going to get this kind of rounded trajectory. And that trajectory, it can go in any direction. It can go up, it can go down, it can go left, it can go right. It doesn't matter. It can go in all directions. On a cube root, it's a double kind of square root. It's an S shape. So it looks something like this. So when we're looking at these kind of pictures, we need to be able to find the domain and range. Well, on a cube, I'm going to jump over here to the easy one. On the cube root, it goes forever left and right, so that's every x value. And it goes forever up and down, so that's every y value. So on a cube, the domain and range is always, always, always all reals. When it comes to square roots, however, the domain is restricted to greater than or equal to 0. And what I mean by that is the underneath of the radical. Underneath the radical is restricted to greater than or equal to 0. And the range is actually going to be whatever is added or subtracted outside of the radical. And it's going to be greater than or less than based on whether this goes up or whether it goes down. So let me just kind of show you what I mean on this. If I have y equals the square root of x minus 2, the picture of this is it starts at positive 2 and goes up. So the domain is x minus 2 greater than or equal to 0, so the x is greater than or equal to 2. See how it starts at 2 and goes to the right? So that's everything bigger than 2. Now the range is everything that's added and subtracted outside of the radical. Well, there's nothing there. So it has to be at 0, and then look at my picture, it goes up. So it has to be everything greater than or equal to 0. Let's have y equals square root of x plus 4 minus 3. Alright, so the way this is going to work, this plus 4 is actually at negative 4. And then 1, 2, 3, negative 3. And it's going to be going this way. So I would say the domain is x plus 4 greater than or equal to 0, so everything greater than or equal to negative 4, because look, it starts at negative 4 and it goes to the right. The range is the lowest point, negative 3, and everything above, so everything greater than or equal to the negative 3. What this comes from is our general format of y equals a x minus h plus k, where h is the horizontal shift, opposite sign, left and right, and k is the vertical shift, same sign, up and down. And we've dealt with this h and k already with our parabolas, and they have the exact same properties. And a stretches it, makes it skinny, makes it skinny, makes it fat. So if I have let's go x minus 7 plus 2. Even without a picture, my domain has to be everything greater than or equal, the inside greater than or equal to 0, so x is greater than or equal to 7. And my a is positive, so therefore it goes up. So my range is everything greater than or equal to 2. Now if I put a negative in front of that, that means my a is negative, which means I go downwards. So my domain is the same, but my range is now everything less than or equal to 2. So A tells me up and down, and therefore I'm either less or greater on my picture, because pictorially this would be at 1, 2, 3, 4, 5, 6, 7, and 2, and it would go downwards. That's not a true point right there. And there you go. So it's 7 and bigger, and 2 and less. This one's at 7, 2, but going upwards. And that's 7, 5.